Recall that in our first example, we simply wrote 3 integers to a file, each on their own line. Now let's write a program to load those back into variables called myInt1, myInt2, and myInt3. First though, let's just see how Python opens the file and what it sees when it does. So just like before, we call the open function to open the file, but this time we're using R for read mode. That just means read the current content instead of overwriting it or modifying it. And then set the results of that operation equal to input file. If we just print input file directly, we might expect to see the contents of the file, but remember, input file doesn't actually represent the file itself. What it represents is a way of accessing the file. So when we print it directly, all we're told is, hey, this variable is of the text.io wrapper class. That's the type of data, so it's not that useful to us right now. Instead, what we need to do is make use of the input file dot readLine method. That method will start at the beginning of the file and read each line of the file one line at a time. So as before, we open the file and set it equal to input file. Again, we're in read mode. And then on line 4, we say to print input file.readLine. Now we know that our file looks like this. And we can imagine that currently there's a cursor at the beginning of the file. ReadLine says read everything between the cursor's current location and the start of the next line. So it captures 12 and the line break at the end. Remember, when we were writing this file, we appended that new line character, that /n, to the end of each line to force these numbers to appear on different lines. And so contained here at the end is a new line character that actually tells it to start printing on the next line. When we call readLine, it reads from the current location to the start of the next line, which means it actually includes that new line character. So when it prints 12 over here, based on that command, it actually prints the new line. And then again, print automatically appends another new line. So that's actually why we see an extra space between each line. It's printing both the new line from the file and the new line that print automatically adds whenever it's called. There are 2 ways we could resolve this. One that we've seen in the past is we could supply that optional parameter at the end and tell it not to automatically add its own new line at the end of each line. Then the only new lines that were printed would be the ones contained inside the file, and it would print what we would expect. But there's another way to do this as well. Since we've now covered strings, we know that there exists a strip method. Strip strips any white space off of either side of the string. In the past, we've said that that's spaces, but it's also new line characters. It's pretty much anything that doesn't print something visible to the screen. So what we could do is call input file dot readLine dot strip. Now that's pretty complicated though. We haven't seen this before. I can only remember one other time in our material where we've seen 2 dots in one sequence. And at the time I told you to ignore it because it wasn't important. But now as we're getting to more complicated things, it can get pretty useful. The way this line works is that input file.readLine returns a string. Specifically, it returns a string containing the next line of the file, which is going to include that new line character that tells the computer to jump down a line the next time it prints something. So in other words, input file.readLine returns the string 12/n, where /n is the escape sequence that says to print a new line character. Whenever we print it, we wouldn't see the /n, it would actually be printed as a new line, but that's what the string really contains. So input file.readLine is replaced by this string, and so now we're calling that string dot strip. As I mentioned, strip will remove any spaces or new line characters from the beginning or end of the string, and so the result will be just the string 12. And sure enough, that's what we see up here in our output. So there are 2 ways we could take care of those extra spaces that were appearing before. We could either tell print not to append its own new line character when printing, or we could use strip to strip out the new line characters that are read in from the file. In using strip, we see an example of how Python chains together commands like this. It evaluates from left to right, replacing each method call with whatever its result is, and then trying to apply the next method to the result of the previous one. So here, it tries to apply strip to the result of readLine. So far, that's all been about just printing the results of reading this file. What if we want to actually assign the results to some variables? Well, here on line 1, we open the file just as before, but instead of printing it, we're going to create the same variables we had before, myInt1, myInt2, and myInt3, and assign them to the results of reading in the next line and casting it to an integer. And sure enough, when we print, we see the exact same results we had before we even bothered writing to the file in the first place. Fortunately, that integer conversion function automatically ignores white space at the beginning or end of the string, and so we don't have to manually strip out that new line character to perform this conversion. So now we have completed the symmetry between output and input. After running this code, the status of our variables or the values of our variables are the same as before we saved the file in the first place.